Hello and welcome to another session of Pistonics. It's Byron speaking, and we are still on our way to building this wonderful, quite addictive, fun game called Catchit. And in the previous session, we have basically managed everything so far. So you would think we are on par with the browser version, but we are not, because what the browser version can do is have some sort of force field that pushes the balls away. But the way this is implemented is kind of crude, so it kind of flips the on button press, it kind of pushes everything away. But what I would like to have is a constant force that you apply. It gets stronger or weaker, or even gets inverted. So let's see how we can manage to implement such a force. Also, the force handling has to be checked, right? Maybe it's as easy as apply set hunter force or apply hunter force or something, and we put in a or during update, maybe, I don't know. So if you press the button, we could possibly say enable hunter force, and if you release the button, we say release disable hunter force. So this is more like an enable set hunter force, and then we set it to true or false. If enabled, a force field is created around the hunter, usually repelling spheres. And the thing is that I would like this force field. People could just have this enabled all the time. And I guess you want it to get weaker, and maybe there should even be some sort of way to ask for this force, like the force strength or something, and the max strength, maybe even, something like that. And yeah, let's see how that can work. It's really like, while it's enabled, we put force in so it can build up. There's a maximum to that. And maybe it's more like a scaling factor or something. And yeah, it could be a scaling factor. Something like that. And it builds up, and then after a while it goes down again. So the forces that are against you get stronger over time. So maybe something like that we can do. So let's see. I just call it force. I think that's something we let's call it hunter force. Where is the state? We have a hunter. Actually, there's something that could call for a hunter object. So now the hunter can have a force. It's something that is related to the hunter, so I would want to stick it to the hunter object accordingly. So let's do that real quick, because then it can keep its data, like transitions and whatnot, itself. And we would be fine. So hunter, as usual, it has an object. That is an object, and it has a force. It is a scalar, and we will see how that will work for us. And yeah, let's see. I think the compiler will just tell me what's wrong here. No. Yeah, that is a bit unexpected. 461. Did I remove anything here? Ah, this is why. Pub fn enable hunter force. Set hunter force. So we can just set it true or false, and enabled. It's a Boolean, and that's all we can do. And right now I have no idea how that would be expressed. Yeah, maybe it's a gradual build up or something. And yeah, we shall see how many variables we need, where we put them. But I think if we stash it, if we have a more complex hunter type, we would be good here and can improve this as we go. So yeah, let's see everything that is related to our hunter. And here, hunter object. Okay, so the drawing should actually be fine now. Hunter object, hunter object position. Again, hunter object intersects hunter object. Hunter object position, and somewhere we initialize it, which is happening right here. So we have a hunter type now. It has an object. And it has a force that should start at 0. And that should be it, huh? Should build. And it does. Good. So now let's try to build up a force. So the force might just, the force could be, we could make it redder or something. The higher the force, yeah, I don't know. We could kind of change the color of the thing a bit. We could make it a bit larger. We could make it larger, so in the moment you get stronger and repel things, you also have the disadvantage of getting larger. That could be something. So we change your size as well, which would mean we really have to manage ourselves properly so that we get back to the original size at some point and not mess it up. Yeah, so let's see. There are many options. First, we have to do this somehow. I'd say, we could try to encode everything maybe into an optional force. Maybe that should be optional so that it can be definitely off. Or we just keep it at 0, and in the moment it's enabled. Yeah. Because it can build up and down, so even if you release it, it will take a while to get back to normal, right? That would be cool. Or we just say, well, you press it and then you kind of pour in power and it will get stronger and then it gets weaker again. Or force time. I don't know. Yeah, we could just turn it on. Yeah, let's start with turning it on. Like, the transition stuff is kind of extra anyway. Let's get the math right to repel and attract. Yeah, I think that should be fine. So we set the force. If we enable it, then we set, let's change our state here. That's S hunter force. If enabled, we set it to something like, well, 1.0. Otherwise, we set it to 0. And that's how that works. And now we can work with it. Somehow means advect. In the moment we advect the obstacles, we now want to make sure that the velocity is affected by the position of the hunter and the force applied. So it's a repelling force. It always acts against you. So basically, if we just compute, if you just subtract the obstacle, oh look, we don't even have. So now we need the hunter. So that's just a hunter here. It's S hunter. Like, oh, we have a state. Dumb. We have a state which we can use. Actually, we don't even want to change the hunter, even though we could. Yeah. So, how often? In which case do we use this? Yeah, we use the field. In a way, it's sometimes better to split up the respective items here so that you don't have to provide a fully writable state, even though you're only allowed or supposed to write a few things, right? So we could be better and safer, but for now I care for easy, and that's what it's going to be. So as hunter position, let's get a vector from the object position to the hunter position. Yeah, so this is kind of the standard direction, it's standard repelling, I think. So position minus the position there is a repelling vector with the strength that is stronger the further it is away, basically. So vec2 sub, like that. And that's the repel velocity that we will then scale down by some factor. So basically there should be some sort of fall off to this, which is probably based on some value. We have access to our field here, so we can just say, well, it's like 4 times our size or something. This is something we could do. 4 size the hunter size. That's where the drop off is for the velocity. So let's see. Let's get the distance. Let obj distance be vec_length of the repel velocity, because that's exactly what that would be. And if so, that's the cutoff here. So if that is larger than, say, S hunter object half size by 2 by 4, or well, if it's smaller, then it should act. And then probably we wanna scale it by that, huh? So let's scale it right away. So if that will then be larger than 1, yeah. So if that's the velocity scale or fall off. So that will be, let's call it velocity scale. So if that is larger than 1, then we are too far away. And I guess I should fix the typo right away. Damn it. Velocity scale. No. I guess we have to move it elsewhere again. I don't know. There's no way to make this look good, is there? Good. Anyway, so if that is smaller or equal to 1, then we can basically invert it and use it as a multiplier. So it's strongest close to us and smallest smallest further away. And then we just have to figure out a good general scaling factor here to make this happen. And yeah, considering this thing is strongest, the closer you are, maybe we get some sort of smoother transition there. Maybe. But we generally don't want this force to be too strong. It should just act over time. It shouldn't push them away in one tick, so that it kind of gives you some abrupt action there. So yeah, let's just do it like that. Velocity scale. Yeah, so I guess we just say repel velocity. Yeah, we just multiply this gleich equals vec2 scale by 1 minus velocity scale. And that's it. And probably this is still rather strong. Oh, we scaled it by the delta time. So yeah, I think that could already be something, because these velocities can be quite high, but thanks to the per tick computation there, it's all per second. So basically we push it away by 1 second, or push it away totally in the duration of 1 second. And yeah, we will see. We might make it even weaker. And so that's the inverse. So that goes to 0 the further we are away. And then we want to multiply this by the Hunter force. So that is 0 most of the time. And this is why this will be a 0 vector most of the time. Right? And I wonder... Yeah, we can just scale this to 0, or we can just set it to 0 otherwise. But we need to compute this anyway. Well... Do we? Yeah, we need to do this computation at some point here, and I think we might as well, have some repel velocity, which by default, that's not Hunter object position. Yeah, some repel velocity. By the way, obj pose, really? But we have... No, it's like this, huh? Damn it. Yeah. Abbreviations. Hate them. Hunter object pose. So, yeah, I think we say, well, repel velocity is if S Hunter force is greater than 0, then it's something. Let velocity be this, and the rest we do here. Or else we set it to 0, which should be as easy as 0.0, 0.0. Right? That's a vec2. Good. And it's velocity, just velocity. We assign it to repel velocity later, and I kind of like it if this is just indented like that. I still like it, I must say, even though it's common to see it like this, and then you save one indentation level. But here we have enough indentation available to do it like that, which might be a bit more readable. It seems more readable to me. So velocity, then we can do it like this, compute the length of the velocity divided by force the size of the Hunter. So that's where it can kind of work, and if we are within that range, So that's the clamp here. We will scale it down by the inverse and by the force. And the force we can then tune in various ways to make it work the way we want it to work. So S Hunter force. All right, here we go. That is that. And we set the velocity, we provided. Ooh. Oh yeah, so if this is too far away, by the way, then we also have to. So then we just return it like that, right? And otherwise we again return a 0 vector here. And we are done. Good. Too far away, apply no force. And then last but not least, you can just add these two forces together to get the new velocity. So that will be the repelling motion here. And then we scale it, of course, by the delta time. So here we go, obstacle velocity and the repel velocity. And depending on the scaling factor here, we could also pull it, right? So if that is negative, it will pull, which is something I would love to implement. So that's the scaling part here. And that's the add part. Oh no, wait. If that's the scaling part, you probably want to do it like that. Yeah. Nothing looks real good, actually. But anyway, so that's a new position that should do something. Let's see if it compiles. If it compiles, we'll then hook up the button presses. Nearly there. Where is that again? 481. Oh, it's not supposed to be. A static method. Not too bad. Function takes 2 parameters, but 1 parameter was supplied. True. 355. So the velocity is scaled down here. And then what else? If and else have incompatible types. Probably there's a semicolon like here. Yeah, cool. So that works. Now mouse presses. Let's get some mouse presses going. Mouse button events we need. Mouse button, piston input mouse button. Yeah, actually we have that in the implementation of the falling sand example. Falling sand source main, mouse press. Yeah, let's see where this happens. Press arc. Interesting. Press arcs. And then you can just check for the button. Good. And if the button is a mouse button, then we do it. And release arcs we also want. So let's just copy this part. We have that somewhere already, do we? So we have the press arcs. Yeah, we are very specific here. This has to change now, because we do support different ones, but that shouldn't be a problem. We just match on this. Match here. Then we put this case here. If it's some space, then do this. Oh, actually we want to do this only if we have a last state, right? And by default, we ignore everything that must be here. So that if last state is not or is some. Maybe I want to have a function that says is game over to make it clear, because this last state thing, yeah, let's have an is game over. And then game over. So this is last state is some. Yeah, actually that's just that. If ab, or is it self here? I think it's self. Can we use self? No. Oh man. Yeah, that's annoying. Yeah, so we will just query this. Game over. Just put it here. One more variable, who cares? Game over is self. Is game over. Nice. So that should work. Now we can test it here. And if self, app is game over, then we listen for space. Yeah, I think that's how I want to do it. Should be a quick check. It's fine. Because we only get this under circumstances, right? Oops. And some here's some mouse button left. If that one is pressed, and that's beautiful, I think. And then we should check for the release arcs. Yeah, in any case, then we say app engine set hunter force enabled is true. That is that. And then we check for the release arcs. And because we only have one, we can say if let sum button mouse button left is e release arcs, then we set the force to false. That should be that. Probably we need to import the mouse button. Key, button, key. I don't know. We will see. Mouse button left. Oh, unresolved name last state. Did you mean self last state? 1, 3, 6. I did. And then it's just the mouse button stuff. Should we get it from here by any chance? Mouse button? And no method is game over found on mutable app. Really? Did I name it? I did name it differently. Game over. Fine. Yeah, I was thinking about it, why I have different names for this, but I actually shouldn't. And now release arcs. That needs a special event, the release event. And then we are done. Press event, release event makes sense. There we go. Nah. So we have to query this beforehand, I guess. Before we do the last state. So everything happens before, because that will do the borrow for us, and then we can't access self anymore. Fair enough. One day it will work. Hey, come on. That is interesting. How can I even do this? So that goes first then. Fine. Shall work. There we go. Okay, so now in theory, I'm able to repel. I'm able to repel these balls. Huh. If it happens... Oh, it was happening a bit, I think. Yep. Yeah. It did happen. Let's look at it. See? They go away. Very, very slow. Yeah, probably you want to press this all the time. So it's right in my path, and there it was pushed away. See this? Amazing. And so I guess you want to press this, but there must be a penalty. There must be some... Woo! Yeah, it's too weak. Maybe we can make the force a bit stronger. And yeah, let's do this. And let's make it relative. Let's make it affect the size, because that makes it more evo. Yeah, let's do this. Must be fun, right? So if you have so otherwise people would just have it enabled all the time because there is a benefit to it. So what if this would, and this, the bigger you are, the stronger the force. So if you make it bigger, it will be better anyway. So we should have some function that computes the sets it up based on the force. Yeah, force offset. Let's have it pub const hunter force offset. Well, hunter force, let's do it like that. It's a scalar and it's 1.0 by default. So we can say, okay, here, and yeah, I want to have a little function that does the right thing for us. So it should produce that force and size should produce both values, I guess, based on the positive or negative value. Huh. Or maybe the force, I will just say plus equals. Yeah. And that is minus equals hunter force, something like that. Yeah, the thing is now the size has to match this. I think it's sufficiently easy to just start with that and say half size plus, we multiply it by 2. Hunter force size multiplier. Size coef. So, oh wait, 1.5. So it gets 1.5 times bigger. And how do we invert this? By 1 by the coefficient, right? So let's see. Now we should see a visual change here. Half size on type hunter, which is not there. True. It's the object that we want to deal with. Okay, so now this is probably easy enough. Forget the extra function and whatnot. Okay, so if I press the button, it gets larger, but also it has a force to it. Let's try that again. Oh, and new spawned ones will also be bigger because that's depending Okay, so that's at some depths. You should leave it out to have smaller ones. And actually you can accelerate them if you are behind them. Yeah, so the force itself, it's still weak. True, because the force multiplier is relatively weak. So I think I want it a bit stronger. So cool, now you definitely have a disadvantage. Huh? This totally works, but it's too weak actually. Yeah, it's actually quite cool. Okay, press space to do this, and then I think I also want to inform the user about hit LMB, use LMB for repelling force. Because I didn't know when I was playing the browser game. People should know when they're playing this one. Nice. So let's see how this looks like now. Let's fail. Oh, yeah, we have to put it onto a new line then, huh? The offset. Do we have text height? We have height by 2 plus text height. Do we have it? Probably we do. Yeah, we do. Cool. Plus text height plus some margin, because that will be very tight. Yeah. It's text height plus text height by 0.4 or something. So that shall be the margin we use here. And it should be better. Let's fail. Use LMB for repelling force. Yeah. Will do, will do. You didn't say that this affects a few things. Yeah, so it kind of keeps it away, but it doesn't slow them down, right? It's really just, this is why it feels so weird. Because it doesn't actually change the velocity. So maybe it should change the velocity, huh? Because that would permanently affect the balls. I don't know if I want to permanently affect them. Huh? Yeah, that's the thing. You have a force that is only so and so strong. This is why you can't slow them down. They will get you. You just can push them a bit away. Yeah. That was fun. Let's play with that. It feels a bit unnatural though. I mean, sure, there is a fall off. I think it feels unnatural because it doesn't permanently affect them. So let's see how it feels if they are permanently affected. Why not? So the repel velocity, then we would actually add that to the velocity for real. Obstacle velocity. And now we add it to that. What do you say? So now the changes are permanent. And it should feel a bit different. Ooh. Yeah, now it's back off. So now these things have no way of getting to me. It's way too strong. Fun though. Okay. It's even though it's scaled, huh? This is already scaled down, yet it's still super strong. Yeah, well, it's in real world space. Probably I wanna scale it by some factor. So we have the hunter force, which is 1. Yeah, so that is not really used here. Yeah, so the bigger we are, the longer our field of force, but the force is not affected by our size. How would we want to introduce the... how do we make it weaker? Just a scaling factor or something? Maybe I just don't want to apply the force here because it's 1, but maybe I want to change. Oh yeah, it should become negative at some point. So this is when this plays a role. So we can negate our force. And that is that. Yeah. Still thinking about it. Probably just a scale factor here that will help. Yeah, so that you can never kind of push it away for good. Yeah, so what's the velocity scale again? Oh yeah, that's the one, that's the fall off depending on the distance. And yeah, so we invert it. That is up to 1, that's fine. Yeah, that's just by 0.1, let's just take it down a bit. So now it should not be strong enough anymore. Yeah, so it slows it down. Can also speed them up. Here you go. There we go. And if we do this all the time, then these guys get much bigger. And thus they are much more dangerous. Yeah, so probably you don't want to do that. So be careful about it. Just use it when you have to, right? Oh no! So probably then you repel all the time. And yeah, I think having the repel animation is also a good thing to have. Animation. Boom. So an animation, but it's at least a state change so people see stuff is going on. Yep. You could also make it redder or something. Yeah. So that's pretty cool. Also with the changes in ball size. So you have some sort of benefit, but also penalty at the same time. So nobody says you can't use the force all the time. This makes our implementation easier as well. Okay, cool. I like it. That's already nice. So we have a full implementation now, 42 minutes in. I think it's a good time to make a commit and and call it a session. So implemented force, feet lib hunter force, repelling hunter force. The force allows the player to repel obstacles at will using a weak but noticeable force. However, this affects the player size and the spawn size of obstacles, which serves as penalty in case it is used all the time. Alright, might still be a bit strong, but I'm not sure about this. And I think my kernel is already spinning. Oh yeah, doesn't like the world right now. So what happens if it comes to me? Okay, it still hits me. That's what it should do. Good. So we are fine. And that is that. So thanks for watching and have a great day.